We are going to see some basic definitions. Holomorphic function. A holomorphic function is a complex valued function of one or more complex variables. That is complex differentiable in a neighborhood of every point in its domain. In a complex plane, holomorphic function is same as analytic function, right? Holomorphic function is a complex valued function with one or more variable. That is a function f x comma y comma z etc etc, like that, more variables. So x y are complex variables, right? That is complex differentiable. It is differentiable with respect to x. Suppose the function is f of x, right? Then differentiable with respect to x. F of x comma y, then differentiable with x comma y, right? Like that. Then that function is holomorphic, right? A complex function is holomorphic if and only if it is analytic, right? Differentiable. Any holomorphic function is actually infinitely differentiable and equal to its own Taylor series, right? So this is infinitely differentiable and it is equal to its Taylor series. A complex function f of x plus I y, which is equal to u x y plus I v x comma y, is holomorphic, where u and v are having first partial derivatives with respect to x and y, and satisfy the Cauchy-Riemann equation. Dou u by dou x is equal to dou v by dou y, and dou u by dou y is equal to minus dou v by dou x. A complex function f is holomorphic on some open set G, subset of complex field C, if and only if dou f by dou z equal to 0, where z bar is the dou f by dou z bar equal to 0. So z bar is the complex conjugate of z. Note, dou by dou z bar is equal to 1 by 2 dou by dou x plus I dou by dou y. Examples: all polynomial function in z with complex coefficients are holomorphic. Sine, cos, exponential function, all are holomorphic. Constant function, that is holomorphic. Next definition, entire function. A holomorphic function whose domain is the whole complex plane is called the entire function. Entire complex field, it will contain, its domain contains entire complex field, that is why entire function. If a complex function is analytic at all finite points, right, sometime it is also called integral function, right? Example: sine, cos, exponential function. Then meromorphic function. A meromorphic function is a single valued complex function that is holomorphic everywhere on the given domain except for a set of isolated points, that is poles. The function is differentiable everywhere in its domain except some points where it goes to infinite. Suppose 1 by x tends to infinite. Suppose if you are having 1 by x, if x tends to 0, the function goes to infinite, right? That is what it is for the complex function. Example: 1 by z, 1 by sin z, tan z, right? When z tends to 0, it will go to infinite, right? Note, integral a to b f of x dx is equal to h into summation I is equal to 1 to n f of xi, where if you can divide the interval ab into n equal parts as x1 equal to a, x2 equal to a plus h, we are splitting the interval ab into small equal parts, right? So etc etc, xn equal to a plus n minus 1 into h is equal to b minus a by n, right? Thanks.